Good morning, and welcome to Lesson 1-3, Equivalent Expressions. The big idea: if different expressions describe the same patterns, then expressions are equivalent. So what we're doing is we're looking at expressions. Remember, expressions do not have equal signs in them. What an expression looks like, if you remember, is made up of numbers or letters and can contain arithmetic options. So for instance, 3a plus 2 is an expression. We don't have equal signs and whatnot. So we're going to see if two expressions equal each other. Okay? Finding equivalent expressions. The picture below shows a sequence of designs made from toothpicks. A sequence is a collection of numbers or objects in a specific order. The objects are called terms. So our terms are going to be our x value. It's what we're putting into our expressions. And then the value that we get out is going to be our y values. Remember, when we have coordinates, it always goes x first, y second. So let's look at this. As I said before, our term number is x, and in this case, our term is going to be our y. Our y is the number of toothpicks. So for term 1, okay, how many toothpicks are there? Well, as you can see, there are 4. For the second term, how many toothpicks are there? 1, 2, 3, 4, 5, 6, 7 total. In 3, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In 4, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 toothpicks. So when x equals 1, you have to get out 4 in your expression. When x equals 2, you have to get out 7 in your expression. When x equals 3, you got to get out 10 in your expression. When x equals 4, you got to get out 13. So this is how Mr. Johnson starts his expression out. Okay? Number 1 says, use toothpicks to find how many are used to make the pattern for the terms 1 through 10. Well, let's use this expression to find the pattern. Well, if you notice, from 4 to 7, we went up 3. From 7 to 10, once again, up 3. From 10 to 13, once again, we went up 3. So, in my expression, I know 3 has to be a part of it. Okay? So that's where I put my variable onto. So I say 3 times x, because I'm going to call x my variable. Now x could be t, because we're talking about toothpicks here. I don't try to get all messed up. Normally, I just like to use x. Okay? Now, if I put 1 in here for this expression, 3 times 1 gives me 3, correct? But I have 4 toothpicks. So, how many more toothpicks do I need if I put 1 in this expression to give me out 4? Well, you all should be saying, well, you need 1 more, Mr. Johnson. How do we say 1 more in mathematics? We say plus 1. Okay? Let's see if it works out for everybody else. If I put 2 in for x, 3 times 2 is 6, plus 1 equals 7. So it worked for term 2. Let's check out 3. If I put 3 in for x, 3 times my x, which is now 3, is 6 or is 9, sorry, plus 1 is 10. That also worked. Let's try 4. 3 times 4 is 12, plus 1 is 13. And since it worked for those 4, I'm assuming this is my expression that works for that pattern, because I just tried 4 different things and it all worked. Okay? Let's move down to number 4 here. Well, let's look at number 3. It says use n to represent the term number. Write an algebraic expression. Right here, instead of using x, you're going to use n. So you're going to say 3n plus 1. Okay? 4 says, use your algebraic expression to complete the table below. So, in my calculation is where I'm going to use my expression. My term number is what n is. Now, in this case, not x, n. They wanted to use n. Okay? Not a big deal. So, 3 times 11 plus 1. Well, 3 times 11 is 33 plus 1 is 34 toothpicks. So if we went out 11 terms, you would see that that would have 34 toothpicks. The next calculation, using 12. 3 times 12 plus 1. 3 times 12 is 36, plus 1 is 37. Notice I'm using my, please excuse my dear Aunt Sally. 3 times 12 first, then plus 1. Here, 3 times 15 plus 1. 3 times 15 is 45, plus 1 is 46. 3 times 100 is 300, plus 1 is 301 toothpicks. So, if we went out to term number 100, it's going to have 301 toothpicks. Let's move on. Activity 2. It says, now consider a different toothpick sequence. The picture at the right shows the number of toothpicks required to construct a sequence of rectangles. The first and second terms are shown. Each rectangle is 1 toothpick wider and 1 toothpick taller than the previous rectangle. So if you look at this, here's 1, 2, 3, 4, 5, 6. So there's 6 toothpicks in this one. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 toothpicks in this one. How many toothpicks are needed for the first term? We said 6. How many toothpicks needed for the second term? We said 10. Okay, simple enough. Build the third term in the sequence. Well, they said it goes 1 long and 1 more height. So it's going to go 3, right? And then 4 across. 2, 3, 4. 2, 3. 1, 2, 3, 4. So I have 8 and 6 is 8 and 6 is now 14. So as you can see, each one of these are going up by 6 to 10 is 4, 10 to 14 is 4, so 4 is going to be my common theme. So I'm going to put 4 here. I'm going to put my n on it because they like to use n, okay? So I need to find the expression that's going to work for all 3 of these. Well, if I put 1 in for n here, 4 times 1 is 4, but I want 6. How many more toothpicks do I need? I need 2 more toothpicks. Let's see if that works for all of them. If I put 2 in for n, 4 times 2 is 8, plus 2 is 10. Does that work? Yes. What term is this? This is the third term. If I put 3 in here, 4 times 3 is 12, plus 2 is 14. Did it work? Yes. So what I'm going to be able to do is use this expression to help me fill out this table. So I'm going to use 4n plus 2 here in my calculations. Well, this becomes 4 times 4 plus 2. 16 plus 2 is 18. And I'm going to skip a couple of these because I think you're going to get the picture. 4 times 13 plus 2. 52 plus 2 is 54. Sorry, 4. Okay? You could go ahead and fill those in. I think you get the idea. Let's move on. I don't want to waste your time. In the activities, you looked at sequences of toothpicks and the number of toothpicks needed to make them. For each sequence, you used the term number n to determine the number of toothpicks needed for the nth term. You or your classmates may have found that there can be more than one expression to describe the nth term. Consider the sequence of dots at the right. Students were asked to describe the number of dots needed to make the nth term. So there's 1, 2, 3. It says Alf explained that in each term he saw 2 columns. So he said he had 2 columns, a left column, a right column, and he had 3 dots in between. That's how he saw it. So in the left column he had the term number plus 1 because 3 plus 1 gave him 4 dots. This is term number 3. Okay? In the right column he had the same, the term number plus 1. And then he had the middle, which is 3 dots. Beth saw this a totally different way. She saw that she had 5 dots on the bottom and the term number in the top in the 2 columns. Okay, 3 here, 3 here, because she counted these in the bottom row. So her expression is 5 plus 2n. Alf's equation is, or expression is that right there. N plus 1 plus 3 plus n plus 1. Their question are both Alf and Beth correct? Let's go to the next slide and let's find out. So here's Alf's expression. Here's Beth's expression. It says compare them for several instances by filling in the tables below. So I'm going to put 1 in for n. If I put 1 in there, I get 2 here, I get 2 there. So 2 plus 2 is 4, plus 3 is 7. If I put 2 in here, I get out 3, plus 3 is 9. If I put 3 in here, 3 plus 1 is 4, so this is 4, so that's 8, plus 3 is 11. If I put 10 in here, 11 plus 3, 22 plus 3 is 25. If I put 20 in here, 21 plus 21 is 42, plus 3 is 45. If I put 35 in here, 35 plus 1 is 36, so 36 plus 36 is 72, plus 3 is 75. Let's check out Beth's now. If I put 1 in here, 2 times 1 is 2, plus 5 is 7. 2 in here, 4 plus 5 is 9. 3 in here, 2 times 3 is 6, plus 5 is 11. 10, you got 20 plus 5 is 25. Put 20 in there. 2 times 20 is 40, plus 5 is 45. Put 35 in there. 2 times 35 is 70, plus 5 is 75. So, for all these numbers that we put in for both of them, did they come out the same? Yes. We would say those expressions are equivalent. Because no matter what number I put in, I get out the same thing. Okay? Quiz yourself. Show that 2w and w squared have the same value when w equals 2. Well, I'm going to put 2 in for 2w. What's 2 times 2? Well, 2 times 2 is 4. Okay? Now I'm going to put 2 in for w squared. So I get 2 squared. Well, what's 2 squared? 2 squared is also 4. So if you were just to check 2, you would assume that maybe 2w and w squared are equivalent, correct? But what happens when you check out when w is 5? Okay? 2 times 5 is 10. 5 squared is, what's 5 times 5? Well, it's 25. Okay? So, since these two things are different, 2w and w squared are not equivalent. Okay? It works for one value, but it doesn't work for every single value. So that's what you got to keep in mind. You can't just check one number. You're going to have to check more than one number. Okay? Check 4 numbers. Check 5 numbers. So on and so forth. Equivalent expressions are expressions that have the same value for every number. No matter what if it's 2, no matter what if it's 10. You need to pick a big number. A big number is going to set it off if they're not equal to each other. Don't try 0, 1, and 2. Try big numbers. And I'm going to put that right here. Try big numbers. For every number that can be substituted for the variables. If 2 expressions produce different results when evaluated for the same number, then the expressions are not equivalent. That's very important to know. If you get out 2 different things for the same number, they are not equivalent, as we just showed. So let's look at example 2. This person and Haley both wrote expressions to describe the same pattern. She wrote k minus 8 plus 5. Haley wrote k minus 13. Are the expressions equivalent? Well, Mr. Johnson said, let's put in a number for both of these. And what I'm going to put in is the number 10. Everybody knows how to work with the number 10, right? So I'm just going to put in here. So I'm going to put in the number 10. If I put 10 in here, 10 minus 8 is 2, plus 5 is 7. Notice I used a bigger number. If I put 10 in here, 10 minus 13 is a negative 3. Are these equivalent? No. Not equivalent. Because I put the same number in for both of them, and I did not get out the same number. If they came out to 2 and 2, then you'd have to try another number and see if that worked. If that worked, try another number. If you tried 3 times and they all work, you're probably good. That's all I have for you today. Best wishes. I'll see you tomorrow.